Good afternoon. We're going to go over lesson 10.4 about nets and surface areas, parts A and B. So first question from part A is determine if each of the following is considered a solid. A solid is a synonym for a three-dimensional shape. So we want to know which of these represents a three-dimensional shape. The blue star does not. That's two-dimensional. That green shape, that is a solid, so this would be a no. That does appear to be a solid. That triangular prism is a solid. It is a three-dimensional shape, much like a box. The triangle insert into a circle, no, and it's not particularly a prism, but that is a solid. It is a 3D shape. So solid, 3D shape. Number 2, determine the total number of faces. Faces mean sides, so how many sides make up that shape, including the bases, the top, and the bottom. Well, what I notice here is each of these bases, the base is a pentagon. So I have a base at the top and a base at the bottom, so that's 2. But because the base is a pentagon, I need 5 sides around the outside. So this would be 1, 2, the one up front, 3, 4, and 5 in the back, plus top and bottom. So this has 7 faces or 7 sides. And to number 3, selecting a net that represents the solid. A net, as a reminder, is just the three-dimensional shape unfolded. So what I have here is a hexagonal pyramid. It's a pyramid with a hexagon at the bottom. So if I were to peel this back, much like peeling a banana, it would look like I'd have a hexagon in the middle. This would be what the net looks like. It would have a net in the middle, or a hexagon in the middle of the net, and then each of those triangular sides would peel down. Now this is a really rough sketch, but a net is not meant to be perfectly accurate, just to give you an idea of what it looks like. So I need a hexagon in the middle and 1, 2, 3, 4, 5, 6 triangles all the way around. So letter A doesn't do it, B does. C has triangles, but it's only 4 of them. D makes a prism, not a pyramid, because each of the little boxes, and I know it's hard to see on the printout, but it's better viewable on the in the Edgems software. This is a hexagon, but it's not just one, it's 2, so this would be a prism. This is a triangular pyramid. This would do it, but it's a pentagon down here. This could be what a pentagonal pyramid unfolds to look like, but we're looking for a hexagon, so this is close, but not it. Could be G. Couldn't be H, because these are not triangles. Those are rectangles. And again, this is a pentagonal pyramid. So the only ones that seem like they make sense in this question are letters B and letters G. To number 4, now we get to some actual number crunching, finding the surface area of the prism, the rectangular prism below. So this is otherwise known as a box. This is just like a standard Amazon shipping box. It's got rectangles all the way around. So if you've ever unfolded a box, and we can draw in what the rest of this box looks like. A box is made up of 6 sides or 6 faces. If we unfold the box, that's what the net's going to look like. But something to notice about a rectangular prism, really any box, the front of the box is always the same as the back of the box. They're the same size rectangles. The left side of the box, the left face, is always the same as the right face. And then the top of the box is always the same as the bottom of the box. Go look at any shipping box, and you'll notice that the front and back are the same, the left and right the same, and the top and bottom are the same. So you have to be a little creative and just try to picture what this would look like if we unfolded it. So I always start with the base. The base is mentioned as 3 inches by 2 inches, so laid flat. And then I draw a 3 kind of on top of the bottom of that rectangle, the base of that rectangle, by 2. Now the front of the box is going to have to fold down. So the front of the box folds down this way. And again, you can experiment at home. You could get a shipping box and cut it open along the edges and lay it flat, and we're going to make this shape. Well, the front of the box is 3 by 8. So this is an 8. And again, I like to write it on top of the side. This is 3. This is also 3 because rectangle. This is 8. We can even fill these in. That's 3. That's 2. Now the left and right both fold down. The left folds to the left and the right folds to the right from the base. So we get a side that goes out this way. And we get a side that goes out this way. And this is 2. I see this is 2 by, again, 8, or 2 by 8. So we already have the 2, so we can label all of the sides. And then the back folds down, the front folded down the front, the back folds down the back. So it needs to be the same size as the front. So it's 3 by 8. And then sometimes what some people do as an error is, remember, a box has 6 faces. We have 1, 2, 3, 4, 5 faces. The top also folds down. So it could either fold down with the front, or it can fold down with the back, or the left or the right. It depends how you take this apart. But I usually will just put the top of it at the top of my net because, it's the top. And it's got to be the same as the base. It's got to be the same size. So we have 6 rectangles, which we should. 1, 2, 3, 4, 5, 6. For surface area, we are just finding the area of all 6 rectangles and adding them all together. So length times width, 2 times 3, and I write that in the middle and circle it. This is 6. This is also 6 because they're the same size. Length times width, or base times height, 3 times 8. Well, that's 24. So this is 24. And then these sides are length and width, 2 times 8, so that's 16. And this is 16. And now I have 1, 2, 3, 4, 5, 6 separate areas. We add them together for the total surface area of this rectangular prism. So we're going to go to the left side and we're going to write this out. So now I'm going to organize. So 6 plus 6 plus 16 plus 16 plus 24 plus 24. And that makes 12. This makes 32. This makes 48. This makes 44. That just comes down. And this makes 92 square inches, or inches squared, as the surface area. Surface area is always find all the separate areas of the sides or the faces of the shape and just add them all together. That is always how surface area works. It's you unfold it into a net, find the area of each of the components, and add them all together. To number 5, what is the surface area of the square pyramid? Well, we're going to do the same thing. We're going to make a net. So I'm going to peel this back. The base of this pyramid is a square. So we draw a square. That's our net. 5 by 5, so I'm just going to put a 5 all the way around. The 5 by 5 tells me it's a square. It also tells me in the written description it's a square pyramid. So the base is a square, and I'm very comfortable 5 around. And then if we, again, peel this back like a banana, there's a triangle, there's a triangle, there's a triangle, and there's a triangle. And we're told the height of the triangle, the distance up the side of the pyramid from the bottom to the point, is 8 feet. So we can draw that in. That's 8. Each of these triangles is the same. So we have to find the area of the 4 triangles plus the square. Well, the square is going to be the easy one. Base times height, 5 times 5. Well, that's 25. So put that in there and circle it. For the triangles, we have to remember that the formula for a triangle is base times height divided by 2, because it takes 2 triangles to make a quadrilateral. We did that earlier this unit. So we have the base of the triangle is 5, and the height of the triangle is 8. So the area of one of the triangles is 5 times 8 divided by 2, which is 40 divided by 2, or 20. Now I'm not going to do this 4 times. They're all very clearly the same size. So each of these is 20. I'm writing it off to the side just for the sake of space. So 20, 40, 60, 80, or we can just do quickly 4 times 20. That's the 4 triangles plus the square we can't forget about. We have to include that. So the surface area of this pyramid is 105 square feet, or feet squared. To number 6. Number 6 is a actually fairly challenging shape to pull a net out of. It's actually quite a rigorous shape. So we're going to see what we can do with it. First, I'd like to draw in, make sure I can see all my faces. I would like to be able to see everything going on. Okay. So we're just going to kind of tick this off as we go. So first I'm going to start at this left side. So this is 9 by 2. So this is a 9 by 2 rectangle. So I have a 9 by 2 rectangle. So that left side is done, and I'm just going to work my way around the whole shape. So, or we could try to draw a net, but this net actually works out confusing because it's a composite solid. So we're going to try to take it piece by piece. So we have this side of this composite shape, that again 9 by 2, around to the top of it, which is 2 by, well, I don't see this measurement. Well, that's the same as this measurement, which is the same as this measurement, which is, oh, the same as this measurement. So this 2 centimeters, this is 2, this is 2, this is 2, and this is 2. So the top of this is 2 by 2. So I've gone up the side, across the top, now down. This is 5 by 2. Now we go across. This is 10 by 2. So I've gone up, over, down, over, just tracing along the outside. Then down 4 by 2. And then it gets a little strange. Well, we go to the bottom. We'll do the bottom first. Go along the bottom. It's 2 by 12. So that's taken me around the left to the top, down to the, I guess, second top, down to the right, and around the bottom. But I still have these front two pieces. So I have this odd looking shape here that has to be dealt with. So I'm going to break that into two pieces, make it a little easier to evaluate. So first thing is this rectangle is just a perfect rectangle, and it's 12 by 4. Now there's two of them because there's this one in the front side and one on the back side. So we have 4 by 12 and 4 by 12. And now we have this piece. So this side, well, I don't have a label. This is 2. I know this is 2. This is 2. And this is 5. This is 5. So I've got this 2 by 5 piece in the front and then again in the back. So we have a 2 by 5 and a 2 by 5. So these are all the little components. And again, this was a very rigorous shape to pull together. So if I multiply all this out, we have 18, 4, 10, 20, 8, 24. Oops, that should be an equal sign. 48, 48, 10, and 10. So these are all the individual areas, and now we just start adding things up. So this is 22, 30, 32, 96, 20, 52, 128, and 20. So that's a fairly reasonable column of numbers to just go over here and add up. 2 plus 8, carry, 6, 7, 8, 9, 10, carry. So this shape is 200 square centimeters. Again, fairly rigorous one. I'd be very happy if numbers 1 through 5 on the Part A assignment are something we could understand. I will share with you the Part B problems on the following video.